ঝিমতে দেব না। আর আমি জানি জানি চোরাবালি কতখানি গিলেছে আমাদের আড়াল। আর আমি জানি জানি তোর এটার মধ্যে হোয়াটসঅ্যাপ আছে? আচ্ছা, suppose for example in the last video we have learnt about the acidic character of phenols, তাই তো? তার মানে আমরা একটা ফেনলকে নিলাম, হলো, এটার অ্যাসিডিক ক্যারেক্টার আছে। কেন আছে? কারণ কি when losing hydrogen ion the phenoxide ion gets stabilized by resonance, তাই তো? The phenoxide ion gets stabilized by resonance which is shown like this. তাই না? The negative charge gets distributed. Now if there is substituted phenols, suppose for example if there is OH and here is an NO2, if there is an OH and here is an NO2, and if there is an OH and here is an NO2, if there is OH and here is a CH3, if there is an OH and here is a CH3, and if there is a OH and here is a CH3, now if I start comparing, due to the presence of electron withdrawing group and due to the presence of electron donating group, NO2 is an example of electron withdrawing group, EWG, and CH3 is an example of electron donating group, EDG. There can be other examples of electron withdrawing and donating group, like for example CN, like for example halogen. Okay, these are all electron withdrawing groups, and electron donating groups are CH3, NH2, and maybe OR, alkoxy groups. Okay, so these are what kind of groups? Electron donating groups, EDGs, and these are electron withdrawing groups. If electron withdrawing group is present, that means it will withdraw the electron this side. When electron will be withdrawn, then the OH bond will become more vulnerable to breakdown, because if the electron is withdrawn from here, are you getting my point? If the electron is withdrawn from here, then what will happen is that the O will pull more electrons towards itself, and hence the tendency to release H plus ion will be more increased. So will be the case of the ortho, para and meta position. But however, the CH3 is electron donating group, and as because they will donate electrons towards the benzene ring, so towards the oxygen also electron will go, and hence as because the electron density around oxygen increases, the tendency to pull the electrons towards oxygen becomes less, and hence the tendency to release the H plus ion is little bit less. So if there is presence of electron withdrawing group, then they are even better acids than phenol. Are you getting my point? They are even
better acids.
Are you getting my point? They are better acids. The other reason for this is that suppose, for example, if we consider that there is formation of phenoxide ion, if we consider that after release, suppose in this case, after release there is formation of nitrophenoxide ion, this phenoxide ion even will be more stabilized than this phenoxide ion, because the electron withdrawing group will pull the electron and stabilize the electron density even more. But do you think that if the case is like this, when this compound will release the H plus ion, so the ion that will negative ion that will be formed will be like this, and it is an electron donating group, and hence it will donate electrons, and electron density here will be increased, so that stability will decrease. So it will be not a better acid than phenol. So all the presence of electron withdrawing group makes the phenol a better acid, makes the nitrophenols or cyanophenols or chlorophenols or bromophenols better acid than phenols, be it ortho, para or nitro. And the presence of electron donating group, methyl phenol, orthomethyl, paramethyl or orthomethyl, metamethyl or paramethyl phenol, whatever is there, these three electron donating group destabilizes the electron density.
This one is meta, right?
This one is meta, yeah. This one is or sorry, ওটা আমার ভুল হয়. Okay. Anyway, so due to the tendency to release the electrons, electronগুলোকে ছেড়ে দেওয়ার, তাই জন্য the electron density here increases, and as because the electron density increases, what basically happens is the phenoxide ion is not that much stabilized. This substituted phenoxide ion, this one, is not that much stabilized as phenol. Are you getting my point? Is this understood or not understood? So that only you will see here. Open this. That only you will see here. See, for phenol the pKa value is 10. What is pKa value? More will be the pKa value, less acidic it will be. Less will be the pKa value, more acidic it will be.
They are inversely proportional.
Obviously, pKa value was there in class 11 acid base equilibria. Okay, so the pKa value, if you see, so if it is 10, okay, now you see for orthonitrophenol, paranitrophenol and metanitrophenol, the pKa values are less than 10. And for orthocresol, metacresol and paracresol, these are cresols. Orthocresol, metacresol, paracresols, the values are more than 10. So that means it is less acidic, and the reason had been explained to you. But do you notice one more thing? Metanitrophenol is a weaker acid. The best one is paranitrophenol. Means, hold here, the best one is paranitrophenol. This one is the best acid. That means this is more stabilized than this, and this is the least stabilized. Again, if you think ulta, this will be the, এখন এটা তো acidity character কমাচ্ছে, so this effect will be more, this effect will be more, so these will be less. This will be the best acid among these three. This will be the best acid, and this will be the worst acid among these three. This will be the best acid among these three, because এখানে কি হচ্ছে, यहाँ पे क्या हो रहा है, the electron withdrawing group is there, and the effect of electron withdrawal is more in this case and this case than this case. So this will not be stabilized as this two because its effect is to stabilize the phenoxide ion, and hence this will be a weaker acid than this two, and that represents here the pK value is more. Again, among this and this will be the best acid among these three. The reason that this is the best acid among these three is because the electron in all the position electron donating groups are there, and this will donate electron and this will donate electron and this will also donate electron, but the effect will be of destabilization of the negative ion, right or wrong, is more in this and this case, not as much in this case. So this will be the best among these three. This stabilizes and this electron donating group destabilizes. The destabilizes style is like the destabilizing effect will be more in this two, as stabilizing effect are more in this two. যেটাই এফেক্ট হবে অর্থ আর প্যারাতে বেশি এফেক্ট হবে, more. Now there should be reason behind this. The reason is just nothing. In ortho and para position the electron density is more. এরকম রেজোনেন্স হয় না, this type of resonance occur in the ortho and para position. If you remember about the resonance, here electron density, here is the electron density, here is the electron density. So if the resonance electron density is here, if electron withdrawing group is present, it will more withdraw electron in these positions, right or wrong, then the meta positions. And if electron releasing group is there, the effect will be more in this position than the meta position. So in meta position the effect is less, but due to the less effect, what you will see is also little bit complicated here, right or wrong. The electron withdrawing group stabilizes the phenoxide ion, and hence the effect of the electron withdrawal is more in ortho and para position, and hence they are better acids than this because they will more stabilize. The effect of the electron donating group is to destabilize the phenoxide ion and make it a less good acid than phenol. So the effect of destabilization will be more in these places. So these two will be bad acids than this. So this is the best of acid among these two, and this is the worst one. Is this understood? Is this clearly understood? And the reason behind that you understood the ortho meta position. Now also you notice that in para position, in ortho and para positions comparison, para position wins. So that means the effect is most in the para position. Why? The reason is in the ortho position they are too close to each other, so they form hydrogen bonding between themselves. This is the reason the effect is little bit less than that, but that is very negligible. Are you getting my point? That's why you see 0.1 difference. Ortho থেকে para 0.1 বেশি acid, 0.1 ज़्यादा difference है. Is this understood? Clearly understood this entire thing? Is there any problem? Huh?
Bit confusing, but
Conclusion is complicated little bit. So I suggest you write down the conclusion. Write down the conclusion. See this.